We now want to discuss the mean or the average or the expectation of a continuous random variable, which can be capital X, capital Y, capital Z. So the expectation, slope of mean, slope of average of a continuous random variable. So because most of you are interested in your X's, we are going to say that if capital X is a continuous, random variable with the PDF small f of x, then its expectation denoted by capital E of x is given by, so our expectation of x is given by the integral from negative infinity to positive infinity of x f of x dx. So the class went through the discrete random variables, and whereas for a discrete, we sum up for all of x, the product of this. For the continuous, instead of using a summation, we use the integral, because a continuous random variable gives probabilities for the integral values or probabilities over the range. So this is our definition of the expectation of a continuous random variable. It has gotten some properties. So these are the properties of expectation of a continuous random variable, because we are in continuous random variables. So we are going to say if A and B are constants, then normally the expectation of the constant A is equivalent to that constant A. Proof: we say the expectation of x is equal to x times the PDF with respect to x from negative infinity to positive infinity. So if it is the expectation of this x which is here is this x. Now if it is the expectation of A, this x changes to A and the rest remains. So the expectation of A is the integral from negative infinity to positive infinity of A, which is a constant, f of x dx. So when you pull out that constant, the expectation of A becomes the integral from negative infinity to positive infinity of f of x dx. And our integral, this is all the expectation of A. So our integral from negative infinity to positive infinity of f of x dx will now become, from the properties of the PDF, we say that the integral from negative infinity to positive infinity of the PDF small f of x with respect to x should be 1. So this whole part here is a 1, and therefore the expectation of A is A times 1, where 1 is representing this integral. my expectation of A becomes A, e.g. So in what we are discussing, if you meet the expectation of any constant, for example, A2 is A2, the expectation of 100 is 100, the expectation of 22.5, you think about it, then think about the expectation of 99. Okay. The expectation of negative feeling is negative feeling. Think about the expectation of 22.5 and the expectation of 99 over 6. Second property. We now want to see what the expectation of AX is going to be equivalent to. So if it is a product of a constant and the variable within which the PDF is defined, then you distribute the expectation symbol on all the terms. So in Roman 2, we have the expectation of AX. We are going to distribute this in, affect all. So it will be the expectation of A, the expectation of X. The expectation of a constant is a constant. Now expectation X, e.g. if we have the expectation of 2x becomes 2 expectation x. If we have the expectation of negative 9x becomes, think about that, Roman 3. It might not be about only 2 variables, but it might be maybe ax plus a b. We still distribute the expectation symbol. So our expectation of ax plus a b will be the expectation of ax plus the expectation of a b. E enters on this plus enters on the last one. This is the same as expectation A, expectation X plus expectation B. The expectation of a constant is that constant, so A expectation X plus a B. The expectation of A is A. The expectation of B is a B. So our expectation of AX plus B will become that, e.g. if you have the expectation of 2x minus 4, it will become 2 expectation, e.g. if you have the expectation of 2x minus 4, this is going to be the same as expectation of 2x minus expectation of 4, which is the same as expectation of 2 expectation of x minus expectation of 4, which is the 2 expectation of x minus 4. So that is the expectation of 2x minus 4. You will try out when it is the expectation of 9x plus 15, Roman 4, the expectation of x squared. The expectation of x squared is going to be, if it is the expectation of x by definition, we say that if you want the expectation of x, then it is the integral. You write negative infinity, positive infinity, what is here times the PDF dx. Now this time what is inside here is a square. So if this is squared, even this one becomes squared. So the expectation of x squared is the integral from negative infinity to positive infinity of x squared f of x dx. That is the expectation of x squared by definition. Then Roman 5, the expectation of ax squared plus bx plus sc. You distribute the expectation now. So you have the expectation of ax squared plus the expectation of bx, this plus this, plus the expectation of sc. This is the product of some two, so you separate expectation x squared, then expectation b, expectation x plus expectation c. The expectation of a constant is that constant. So it is a for expectation a, and expectation x squared remains. It is b for expectation b, and expectation x remains, plus c for expectation c. So that is the expectation of x squared plus bx plus c. E.g., if you have the expectation of 3x squared plus 9x minus 15, you will think about that, and then we go for the example. Please, you check the next setting. It has the example how we can apply those properties of expectation. The question is to do with the continuous random variable.